Thanks for the introduction. It's great to be here. I just flew in this morning with the 6 a.m. flight from Budapest, so I hope you'll enjoy the presentation. And it's the only one that's not red, so it's blue. It's Prezi blue. I flew in from Budapest because that's where the Prezi office is. So Prezi is a cloud-based presentation software company. We have offices in Budapest and San Francisco. We have about 200 people, 75% in Budapest. And I am one of the managers of the data team. By the way, if you like what you see, then check out Prezi, prezi.com. It's free to try out, free to register. Over 60 million people have done so already, so not everybody can be wrong. And usually when I give talks like this, I talk about our data infrastructure and how we grew the data team. When I took over the data team 2 years ago, we were 5, and at the highest peak, we were 19. So it was quite an interesting journey, but not today. Today I will talk to you about A/B testing, and specifically about the 10 pitfalls of A/B testing, or not but 10 pitfalls of A/B testing. The context of the talk is that about 6 to 9 or something like that months ago, the data team started to address the problems of A/B testing in Prezi, which was historically performed by product teams. And these are the pitfalls that we identified, not just at Prezi, but also at other companies that we visited, and what to do about it. Okay? So the outline of the talk is really simple. I'll show you my 10 favorite pitfalls. You'll notice I'll be quite enthusiastic about them. They're very simple, but they're pitfalls. And then I'll briefly talk about what you can do about them and what we are doing about it at Prezi. All right, so let's get started. The first one is very simple. I call it the pitfall of non-randomized bucketing. So this is something that has happened in real life. So you want to run several A/B tests, and so what do? The simplest thing you can do is take, for example, your user's user ID, and it's basically just take the last 2 digits and use that to make your groups and your buckets. So suppose you're a product manager, you want to run an A/B test, and you say, okay, I'm going to take the users whose ID ends in 70 to 79, so that's a 10% bucket. So a 10% group, and it's an A/B test. So I'll use 70 to 74 for my A bucket and the rest for my B bucket. Great, I run my A/B test. It's so simple. What could go wrong? What could go wrong? Well, a bunch of things can go wrong, and they do go wrong. So first of all, the biggest problem with this is that in this continuous scheme where you use this continuous, let's say 10%, you can only do so many groups. So if like every product team gets 10%, then you only can have 10 product teams doing A/B tests, and probably only one each time. So that's obviously not very scalable. That's, I think, the biggest problem. But there's of course many other. The second one, non-random distribution of user IDs. So if you have like a distributed system that's assigning the user IDs, it's possible that the users with user ID ending in 72 are more likely to be from China, and that will foobar your A/B test. The third one is if you don't do this continuous scheme, then you can have overlapping groups defined like this. So another product team is maybe using 60 to 99 for a group, and they're splitting exactly where you're splitting. So then in the end, you will be measuring maybe the other team's effects. Very simple. Or and the last one, that's my favorite because it's such a, I think it's hard to sort of guess. But what if somebody else used the same scheme a month ago and ran a test, and you don't even know about it because maybe that person is not even around anymore, and you're still measuring the effect of that test. That's a real cutie, right? But fortunately, the solution is very simple. You just have to implement it. You have to use a randomized hash-based bucketing. So it's basically you just take we can assume each A/B test has a name, and there's some IDs for the users, like a user ID or a session ID if they haven't registered yet, and you can just do a hash on that. And that way you can actually have many overlapping tests running, almost infinitely many. And your product teams can run them independently of each other. So this one is very simple to address, fortunately. The second one, this one is more a social pitfall. This is the pitfall of assuming that your stakeholders understand statistics and things like statistical significance, and I'm not sure if you can see type 1 error, type 2 error, null hypothesis, and what's the difference between statistical power and significance, and confidence levels and different tests. So this is actually something I've seen happen in real life, where somebody ran a test, and they want to, of course, you want to show results, but you input it into the little calculator, and it says, well, it's not significant at the 95% level. So you say, okay, what about if I put in 80? And then it's, yes, it's green. So then you go to your stakeholder and say, well, it works at the 80% level. So then your stakeholder says, oh, so that means that we're 80% sure that this works. Well, that's good enough for me. We can go with that. But right, that's not what it means. We know that that's not what it means. And this one is pretty, I think, it's sort of a social issue. You can't really expect all your stakeholders to be mathematicians or statisticians. In my opinion, and what I advocate, is the use of Bayesian statistics and not frequentist statistics. Frequentist statistics is when you have statistical significance and all that. If you use Bayesian statistics, then the outcome of your test is actually a much more easily understandable number. Basically, the probability that, let's say, the click-through rate of your A bucket is better than the click-through rate of your B bucket. So the outcome is something that you can almost tell your stakeholders, and then they can make a decision based on their thresholds. The frequentist way is very confusing. Next one, peaking. This is also very cute. So, by the way, who knows what peaking is in A/B testing? The pitfall of peaking. 1, 2. All right, interesting. So imagine you're a product manager and you set up an A/B test and you run it, and it's been running, let's say, for 3 days. And you want to see, does it work yet? What's going on? So it's very simple. You go to the internet, you take one of those easy and nice A/B testing calculator tools, and you take your 4 numbers. How many people did I get in bucket A? How many people did I get in bucket B? What was my conversion rate, if that's what you're using in A, and what was it in B? And you input it into the calculator, and of course you put in that magic number 95. And probably the other magic number they don't ask, and then it says, it's not significant. Oh, crap. So then you run it, you wait one more day, and then by 4th day you come in and, I really want to write that email to my head of product. So you go back to the tool and you enter it again, red. And by the 5th, let's suppose on the next day, on the 5th day, it comes out significant. So then you're, yes, it worked. But you're shooting yourself in the leg, because if you do this, you're not actually operating at the statistical significance level that you think you are, because you're repeatedly testing on the same data. So your significance level, even though you enter whatever you enter into the tool, like 95, it will overall, if you repeat this process many, many times, be as low as 50. So you should, in theory, never peak. You should have a hypothesis, figure out how many samples how many users you're gonna show it to, and then only test it once at the end. Or you can check in the middle, but you're not allowed to test. Basically, what you're doing is you're looking for a fluctuation when the thing fluctuates up, and you stop as soon as that happens. But that's a fallacy. You will make a statistical error more often than what you think you are doing. Of course, again, my suggestion is to use Bayesian statistics. It's very nice. It solves a lot of these pitfalls. In Bayesian statistics, you get that simple probability, and that is not subject to this problem of statistical peaking or peaking. Next one. This is also very cute. This one I also saw in action. This is what I call the fallacy of reporting raw lifts versus projected lifts. So let's imagine the situation that you have a product, and there is some very basic metric or KPI that you were measuring against, or that you're using to report on. Let's say it's activation, and let's say that we know that activation is 3 out of 10, so 30% on your product. And now you want to work on a feature. So the feature is depicted by this little glass, and you wanna change something about this feature. So first of all, let's say we know that the people who actually use this feature within the product, their activation ends up being, let's say, 40%, whatever. Right? And now we want to change the feature. So we set up an A/B test. In A is the control, so we leave it the same. So let's assume that activation stays the same 4 out of 10. And then we make some changes here. That's the experiment. And let's say we run it for however long, and yes, it worked. It's 5 out of 10, 50% activation. It really works, right? So now you're really happy. The product manager is really happy. We raised activation from 4 to 5 by 25%. Let's deploy to all users. We all get a raise. Yes. And you send this email to the CEO. And then he says, of course, you should deploy to 100%. But then let's say 2 months later, your CEO comes back and says, you said you raised activation by 25%. And shouldn't that mean that I should see this big jump in overall activation? What's going on? Well, what's going on is that you did raise activation by 25%, but only for users who ever reached that feature within your product, right? So if, let's say, only 1% of overall users ever use that feature in your product, then not exactly, but in terms of order of magnitude, you will only have raised activation by 1% times 25%, which is like 0.25%, which is, by the way, still very good, probably. But the expectation that you set by misreporting or not distinguishing your raw lift in your feature versus versus what I call the projected lift, which is what you will see when you release to 100%, that can lead to trouble. So my suggestion is to have standardized ways of reporting your A/B test. And one of the things that you should standardize on is to report both the raw lift that you achieve and what metric you're lifting, and what I call the projected lift, which is what happens when you will deploy to 100%. And that will avoid really weird emails from your head of product or CEO. Number 5, this is also something that happens a lot. It's the fallacy of data mining segments and data mining KPIs. So I think you can guess what it is. You run an A/B test. Let's say you run it for a month. So you invested a lot of time in it. And a lot of data comes out, and let's say it doesn't work. So there's no statistically significant lift, or there is a statistically significant lift, but it's like tiny, and you're not happy. So what happens? Well, of course, you have probably access to a data team or some analysts. So then you start looking at all sorts of segments, right? And eventually, if you look at a lot of segments, you will find something where you will see something. Or the other thing is, you don't look at the segments, you look at the KPIs. So you probably have a whole bunch of KPIs that you can look at, and eventually, again, if you look at the outcome in terms of the KPIs, you will probably find one where there's a lift. So that's what happens. Overall, my A/B test didn't produce but if I look at German mail users with a pro account, there is something going on. It's great, right? And that's what you want to report, because you spent all this time on, and you want to be successful, and you want to feel good. Except if you look hard enough, you will eventually find something where there's a lift. So 2 suggestions. 1, have a clear hypothesis and fix your target KPI before you conduct the test. And that's the only thing you're really allowed to sort of report on. But but you should actually data mine and look for these segments, but you should understand that you're playing a game of chance, and there's a chance that you just found that there's a good chance that which by the way you can calculate, that what you found is just a fluctuation, but no problem. Suggestion number 2, repeat test after finding interesting effect in segment. So you have to repeat and again sample reality, sample the cosmos to see whether that's real or not. Otherwise, you may be fooling yourself. Can't see the number. All right. The next one is also something which I've seen happen. It's very cute. You have a product team, and they write a feature, and they have but they're very disciplined. So they have a control where they don't deploy the feature, and they have a B where they deploy the feature, and they're measuring the outcome. Great. So let's say that they deploy it, but then what happens is that you can't have your programmers not continue working. So they continue to work and write code, and so eventually, let's say a week later, you will have a new version of the thing out, and then what do you do? So what happens what I see happen in practice is that they will deploy it into your B variant. And then this will go on and on and on, and basically what happens is they run a test for a month, but in reality, during the month, they deployed 4 versions of the thing. But of course, they want to get all the data so they can input the big numbers into those tests, so they have green things coming out of the significance. But this is a fallacy, right? I mean, at the end, you will deploy the thing that's at the very end, so you should only look at that window when that thing was out, which may only be like 3 days. Sometimes they even deploy something, I've seen cases when they deploy something that wasn't even part of the A/B test because the last version came out at the very end. So this is something where, by the way, there's no pink box. You just have to be disciplined. And if you release a new version or you deploy a new version, you have to start your A/B test over. Or you have to have a great sense of belief in what you're doing. All right, we're at number 7 already. I think this is pretty common. This is probably known to everybody here. So it's the pitfall of daily variation versus significance. So suppose you're running on a site which has a lot of traffic. So a simple example to imagine is like Google. And that means that you can run your A/B test even for, let's say, just an hour, and you will have like millions of hits in both your buckets. So when you run it either against a frequentist or a Bayesian model, the thing will tell you, okay, I can already tell you what's going on. So significance or whatever you use will be hit. But of course, what happens is that if you ran the thing for an hour, most likely what happened is you got users from China being overrated because that's when the sun is up in China and everybody in the UK is asleep. So this is a fairly simple thing, and the suggestion is also simple. At Prezi, we try to run things for multiples of 7 days, so we get, of course, whole days, and of course you want to get whole weeks, so you avoid the weekend versus weekday traffic effect. Okay. Number 8. So I was sort of thinking about what I should call it, the pitfall of seasonality or the pitfall of running your A/B test against all users versus the users you are shooting for. So I'll give you an example. Suppose you're in the lucky position where you have a lot of different types of users for your product. So let's say you have students and business users both using your product, and maybe even both paying for your product. So it can happen that you perform an A/B test and you get different, for the same imagined A/B test, you get different results in July. Suppose in July you could see that A is better, but then in October you see that B is better, right? Because what happens is that in July all your students are surfing or whatever, and then in September they come back, so then in October the weighting of your user population will be different. So you could run the same A/B test and get different results depending on the time of year, seasonality. So this one is again, this is actually not a mathematical pitfall, it's more a business pitfall, I think. The suggestion is that you should be clear with yourself about who your target user is and who you're shooting for. So it's probably not both students and business users. So let's say it's business users. So in that case, you should actually run your A/B test against business users only. So you should have a way of identifying your users, maybe self-identification, and you should only run your A/B test against them. Which, by the way, takes quite a bit of discipline because it means you only use a subset of your traffic and users for an A/B test. So it's like, I know it's very hard to say, oh, but I have to run it for 3 times as long because I can't use those other users. Number 9, conflicting test. This one is very nasty. Yes, I'm almost done. That's number 9 out of 10. Okay, so this one is when you have several product teams and they all want to move fast and they're all running product teams. And what happens if both deploy an A/B testing onto your, let's say, your landing page? So one of them deploys like a nav thing and the other guys deploy like a sidebar. Yeah, chances are that they will conflict. This one is an organizational issue, really. There's 2 ways that I can think of to attack it. One is to have some sort of person where all A/B tests run through, who sort of acts as a multiplexer. That, in my experience, doesn't work out very well because it's very tough to get a distributed organization to sync on one person, because what if that person goes away on vacation or whatever? And by the way, it's not a very nice job description to be like an A/B test mutex. But actually, it's pretty simple to address with automation. And there's actually two things you can do that we're trying to do at Prezi. The first one takes a bit more discipline. It's where you create a tool where you require your product teams to register the A/B tests before they run. And then this registration form basically can have a field like a module. Which module is your A/B test running against? And then one of them can be the landing page. And so if two teams register a test for the same or overlapping times for the same module, then you can at least send them an email like, hey, you should talk to Bob. Looks like Bob is also running an A/B test there. This one takes a bit of discipline because you have to get them to use this registration mechanism. The other one is even simpler. In some sense, if you can get them to log in a way where they include the module in the A/B testing logs, then you can actually alert on this in real time and just check the logs. Do I have different logs coming in? So do I have logs coming in from two different experiments that are running in the same module? And in this case, you can notice this as it happens, and then again send an email or to them or to yourself and make sure that they resolve it. And then the last one, in some sense the most important one, don't forget to remember tracking. So this is the pitfall of not tracking your A/B tests. So imagine that you work at a company and that, let's say, a new head of product joins, and you tell them, oh, we have this great A/B testing culture and we run a lot of tests, and he says, oh, great. What did you do this week? What did you do this year? What were the tests that you ran, and what were the outcomes? Yeah, you have to have a place where you track your A/B tests, and that way you can go back and, for example, see what happened this year, and not just see what happened, but also hopefully see how the A/B test moved your standard company KPIs, raw versus projected, all that stuff. Okay, so this was the last pitfall and what to do about it. So I did address this sort of in line as I was going through them. So there's the hard part. You have to be disciplined. In some cases, it requires coordination. In many cases, it requires a scientific mindset. So you have to understand what statistical significance means, or at least somebody has to understand it. Or you have to understand why Bayesian is worth it and maybe use Bayesian. That's what I would do and what we are trying to do. Fortunately, there's great sources to read up on. There's those two books, Think Stats, Think Bayes, written by the same guy. And there's this blog called evanmiller.org. If there's one thing you take away from this talk is that you should go and read evanmiller.org if you care about A/B testing and perhaps you're interested in Bayesian. He's great about the Bayesian stuff. And the easy part, or the win, is that there's a lot of win you can get. So lots of these pitfalls you can address by automation, which means that you don't have to be disciplined. Or you can be less disciplined because of automation. And this is what we're implementing right now in Prezi. So we wrote, and this is my last slide, we wrote a tool called Abacus, which is a play on A/B testing, obviously. And I didn't come up with the name. But it's funny, yeah. And so Abacus basically has, if you think very roughly, it has basically two views. One is a list of all A/B tests that the tool is tracking. So that's where you would see what you have done and what you have learned. And then if you click an A/B test, then this is what you would see. And this is basically a very standardized reporting screen for A/B tests. So the nice thing is that it supports both frequentist and Bayesian statistics. We still have to show frequentist because I haven't quite sold it to everyone that they should just look at Bayesian. It shows the predetermined stopping conditions. What's really cool is that we have all the company KPIs in there. So we don't just look at, in fact, we don't even look at CTR that much because most of our A/B tests are running inside our product. But instead we have standard KPIs like consideration, activation, retention, views, shows of Prezis. Yes, and we show raw and projected lifts, so there's no confusion. And yeah, we have Bayesian. So it's a pretty cool tool. This talk is about the pitfalls and sort of the soft technical issues. I could do another talk about how hard it is to try to implement and sell this to the organization. And that's sort of it. Of course, there are more fallacies. There's probably 100 if we would make a list, but these are the 10s that I encountered recently and most frequently. And I think the thing what's interesting about these is that they're pretty simple, but they still happen, and they invalidate many of your conclusions. So that's it for me. I'm happy to hear any questions.
Thank you. All right, let's start over there. Hold on. Wait for the mic.
Oh, thank you.
Okay.
How do you go about selecting what prior distributions to use for doing your Bayesian testing?
We're not very sophisticated yet with Bayesian, so we use like a uniform.
Okay, and secondly, how do you go about getting buy-in for doing Bayesian stats in your work? Because I find in my industry, although it's actually harder to interpret frequentist statistics, everyone seems to think it's simpler, and so we're very reluctant to use Bayesian methodology.
So at my company, I think the buy-in for Bayesian is not hard at all, or it's almost a non-issue because in my experience, the frequentist stuff is also not known very well. So it's actually just a more useful number. I actually find that it's better to not even talk about it. You just report on the number that's more easy to understand, and that's it.
Okay, second question. Okay, I gave you one before, so I'm gonna give this one to him. Okay, great. One moment. There you go.
Lovely talk. With the Bayesian stuff, how do you deal with multiple testing correction? Like there are various established methods for dealing with multiple testing correction in the frequentist world. What do you do in the Bayesian world?
We're not at that level of sophistication yet, I'm afraid.
Because the problem might be then that if you're running loads of tests and you take your posterior density as the truth, then you might be misled equally as you would be misled by using a frequentist method.
Maybe we can talk about this offline.
He got you. He got you.
I'm a manager.
It's all right. You'll be fine. You'll be fine. You can hash it out during the break. Okay, we have a coffee break, everybody. And after this, there'll be a workshop.